Hello guys, today we are going to discuss about welding. In previous classes we have discussed about the connection by rivet connection or bolted connection. Now another connection as we have discussed, that is welding, which is very important in steel structure design, we will discuss today. Welding is basically a connection process. This basically connect two metals by the application of heat with or without pressure. That means, if we have an angle here and if we have another angle here, then we can connect these two through some welding process. In place of riveting, in the earlier cases we have seen that we are going to make some rivet joint. So, in place of riveting joint we can make also this welding process. Basically mild steel, cast iron, copper, brass and aluminum can be welded by application of heat. Now, let us see what is the definition of the welding. Basically, welding is the process of connecting metal pieces by application of heat, which is called fusion, with or without pressure. Now, the process of welding can be classified into these 5 category. One is called forge welding, another is thermite welding, another is gas welding, then resistance welding and another is electric arc welding. Out of all these, the structural members are generally connected by electric arc welding. So, we will be only emphasis on this. Now, what is forge welding? I will shortly discuss about all these welding type. In forge welding, the edges to be joined by applying an extremely high external mechanical pressure. In case of thermite pressure, this will be thermite welding. In case of thermite welding, a mixture of iron oxide and aluminum called thermite is ignited. Iron oxide reduced to molten metal is deposited at the joint. In gas welding, the edges are to joint are melted on oxyacetylene gas flame. In resisting welding, the parts are to be joined are pressed together and current is passed from one end to another. When welding temperature is attained, mechanical pressure is applied to force the weld. The mostly used welding is electric arc welding, where heat is applied by means of an electric arc struck between the parts to be welded and an electrode is held by a welded or automatic machine. During welding, the electrode melts and fills the gap at the joint. The arc welding is further classified into these 3 categories. One is called shielded, another is called unshielded and then submerged. Now, according to their position, welding can also be classified. These are classified into 4 categories. One is called flat welding, another is horizontal welding, then vertical welding and then overhead welding. So, according to their position we can classify the welding into these 4 categories. Out of these 4 categories, generally people are using this flat welding mostly. So, flat welding, horizontal welding, vertical welding and overhead welding. In case of flat welding, it is the one that is made right on top, the electrode being downward in a vertical plane, and it looks like this type of figures. Next, in case of horizontal welding, it is made on a horizontal side, the electrode being in a horizontal plane or only slightly inclined. Axis of weld will be in this way and welding will be in these cases. Another is vertical welding. It is made from the bottom upward on a vertical plane. Axis of weld will be vertical and the two members can be connected in this way, which is called vertical welding. Next is overhead welding. It is made from below looking up, the electrode being upward in almost vertical plane. This is looking like this, axis of welding will be like this or like this, and it is connecting in this way. Now, among those mentioned this 4 type of welding, flat welding is the easiest and overhead is the toughest. During the fabrication, detailing is adapted in such a way that the overhead welding is reduced to minimum. Now, while discussing about the welding, we must look into the advantage and disadvantage of welding process, because we know we can join the 2 structural members by riveting, 2 steel members we can join by riveting or bolting. So, why we are going for again welding? So, before starting to welding design, we must know what are the advantages over the bolted design and the rivet design, then what are the disadvantages, that also we have to look, and then only we can, means designer can choose which type of joint will be required, which type of connections will be made. Basically, we cannot suggest thoroughly that welding is better or bolting is better or riveting is better. So, it depends on case to case. So, the type of connections we have to see first, then accordingly at the, sorry, I am repeating once again, this can I repeat once again? So, before going to discuss details about welding, we should know about the advantages and disadvantages of welding. We have seen how to connect 2 steel members by bolting or by riveting. Now, we will see how to connect these 2 members by welding. Welding connection has certainly some advantages, but it has some disadvantages also. So, let us discuss about these advantages and disadvantages, so that the designer can choose certain type of connections for a certain type of structures. So, one advantage is that as no hole is required for welding, hence no reduction of area. So, structural members are more effective in taking the load. In case of rivet joint, holes are there. So, because of holes, the net effective area is going to reduce. That is why the net strength of the plate after riveting is going to reduce. But in this case, in the case of welding, there will be no scope of reducing the area. So, we are going to get full strength of the plate. So, this is one more, means one advantages which the structural engineer has to look. Another is, in welding, filler plates, gusseted plates, connecting angles, etc., are not used, which leads to reduced overall weight of the structure. Then welded joints are more economical as lesser labor and less material is required. The efficiency of welded joints is more than that of riveted joints. That we have already told, that why efficiency is more. The welded joint look better than the bulky riveted or bolted joints. In case of riveted or bolted joints, because of rivet head or bolt head, this will look bulky, the joint will look bulky. But in case of welded joints, we can just simply by pressing or without pressing, with the application of heat, we can just join the 2 members. Another advantage is the speed of fabrication is faster in comparison with the riveted joints. Complete rigid joints can be provided with welding process. This is another important advantages in case of welded joint. The alternation and addition of the existing structure is easy compared to riveted joints. No noise is produced during the welding process as in the case of riveting. The welding process requires less workspace in comparison to riveting. Any shape of joint can be made with ease. This is another means important point which the structural designer has to look, that any shape of joint can be made, where the in case of riveted joint it is little difficult. Now, what are the disadvantages in case of welding? The major disadvantage is that welding joints are more brittle and therefore, their fatigue strength is less than the members joint. So, this is one important thing which has to look into while designing the steel structure. Due to uneven heating and cooling of the members during the welding, the members may distort, resulting in additional stresses. So, because of distortion, additional stresses may develop in the member. So, that has to be taken care. Skilled labor and electricity are required for welding. This is one important thing, we need skilled labor for connecting two members by the use of welding. No provision for expansion and contraction is kept in welded connection, and therefore, there is possibility of cracks. So, possibility of cracks will be there. Another important aspect is that the inspection of welding work is more difficult and costlier than the riveting work. So, inspection is difficult, inspection of welding work, this is one major disadvantage in case of welding joint. Another thing is defects like internal air pockets, slag inclusion and incomplete penetration are difficult to detect. So, whether the joint has some fault or not, that we cannot detect easily through the means if the joint is connected through welding process. So, this is another, because the failure may occur suddenly in case of welding joint. So, we cannot keep track. In case of riveting joints, this type of disadvantages will not come into picture. So, keeping all this mind, the designer has to choose whether he will go for welding joint or riveted joint. Now, types of weld, basically these are divided into three types on the basis of their formation, how it is forming. This one is called fillet weld, another is butt weld and then plug weld. So, this basically these three type of weld we will be looking for designing of steel members. So, we will see all this in details later. Now, we will discuss about some basic types of weld and their symbol, because when we will go for designing the steel members, we have to know what type of symbol we used in drawing. In drawing it has to be used so that the user can read it and can make accordingly. So, let us see how it look like. In case of fillet weld, we will see the sections will look like this. Say one plate is connected with another plate with fillet weld, then if it is fillet weld, the section will look like this and symbol will be simply like this. And in case of square butt, this will look like this. This will be like this. So, section will be like this and the symbol generally can be like this. Sorry, this will be like this. Now, in case of single V butt, the sections will be looking like this. This will be like V shape with having some round here. This will be filled by the weld. Now, this height is 0.7 to 3 mm. This height, this is the round height. Then this width will be 2 to 15 millimeter, and this angle will be minimum 60 degree. Minimum angle will be 60 degree, and the symbol will be simply like this. So, this will look like this. Now, if it is double V butt, then simply in two side it will be. So, we can see the picture will be something like this. So, this is filled with weld and the symbol will look like this. So, in double V part, in both side it will be, this thickness will be around 3 millimeter and this will be, this thickness will be 0 to 15 millimeter and this angle will be minimum 60 degree. So, the detail of the double V bar joint will be like this. Now, in case of single U bar, this will be looking like this. This is single U bar and this will be the symbol. This is symbol. Then in case of double U bar, similar to single U bar, it will be only in two side, it will be top and bottom. The welding will be there in this type, which is called double U bar, and the symbol will be simply like this. In case of single level bar, the sections will look like this. And the symbol will be like this. So, single bevel bar will looking like this type. Then double bevel bar will be in two side, basically similar to single bevel bar, only it will be in two side. That means, this will be like this and this will be in this way also, like this. So, the symbol will be simply like this. And single J bar will be like this. This will be, section will be looking like this and the symbol will be looking like this. And in case of double J bar, similar to single J bar, the section will be only in two sides, it will be. And this will be looking like this. And the shape of weld can be make, in case of flat weld, the symbol will be like this, and in case of convex weld, this will be like this, and in case of concave weld, it will be looking like this. Now, we will classify the welding process into different categories. Say welding, this can be classified into three categories. One is called welding with pressure, welding with pressure. Another is welding without pressure. without pressure, which is called again fusion welding. Welding without pressure is also called fusion welding. And another category is brazing and bronze welding. Brazing and bronze welding. So, these three type of category can be made, where this again will be of 5 types. One is called resistance welding. Resistance welding. Another is force welding. Another is pressure welding. Pressure welding. Then stud welding, and the last one is thermite welding. Thermite welding. So, these 5 category is coming. Then again, if we see resistance welding can be classified into 4 categories. One is called projection welding. Projection welding, then spot welding, next is seam welding, and the last one is flush butt welding. Flush butt welding. So, these 4 type of resistance welding are there. Again, this projection welding can be divided into 3 categories. One is called multiple spot welding. Multiple spot welding. Then series spot welding. Series spot welding and stitch welding. So, projection welding again can be classified into 3 categories, which is called multiple spot welding, series spot welding and stitch welding. So, again this welding without pressure, which is defined earlier, that can be classified into 3 types. That means the fusion welding. This can be classified into 3 categories. One is called arc welding, then gas welding, and then thermite welding. Or this is fusion welding. Again, this gas welding can be divided into 3 categories. One is called oxyacetylene welding. Oxyacetylene welding. Another is oxyhydrocarbon welding. hydrocarbon welding, and the third is oxyhydrogen welding. Oxyhydrogen welding. So, this gas welding can be classified into three categories. One is called oxyacetylene welding, oxyhydrocarbon welding, and oxyhydrogen welding. Then again arc welding, this also can be categorized into four types. Arc welding, this can be divided into four types. One is called metal arc welding, then carbon arc welding, then inert gas welding, and atomic hydrogen welding. So, this arc welding can be classified into four categories. One is metal arc welding, carbon arc welding, inert gas welding, and then atomic hydrogen welding. So, this again we can summarize in this way, that welding can be categorized into three: welding with pressure, welding without pressure, which is called fusion welding, and brazing and bronze. And this welding with pressure can be categorized into this five category. One is resistance welding, another is force welding, then pressure welding, stud welding, and then thermite welding. Again this resistance welding can be classified into four categories: projection welding, spot welding, flush butt welding, and seam welding. Again this projection welding can be classified as teach welding, this multiple spot welding, and series spot welding, and seam welding can be again made into spot welding. Then this welding without pressure, this can be classified into three categories. One is called arc welding, then gas welding, and another is thermite or fusion welding. This arc welding can be of metal arc welding, carbon arc welding, this will be carbon arc welding, inert gas welding, and atomic hydrogen welding. And gas welding will be oxyacetylene welding, oxyhydrocarbon welding, and oxyhydrogen welding. So, these are the different categories of welding. Now, some drawing we have to know how to represent different type of welding in the drawing, because the designer has to read from the drawing and they have to implement in the construction. So, this has to be known. So, let us see how drawing can be done. One is we can make in a tabular form, one is form of weld. What type of weld formation is going on, then section, and then drawing representation, means how in the drawing we will represent, drawing representation. So, in case of flush butt welding, means form of weld will be flush butt. So, section will look like this, and drawing will be representing in this way. This is very important, because in drawing we have to understand how it has been represented and what does it mean. This is the representation of flush butt, plus this is flush square butt. So, in this way the designer has to represent in his drawing. Then say for machine finish, in case of machine finish, the section may be look say suppose like this. Then in the drawing it can be represent like this. This will be simply like this, then it will look like this. So, this is double V butt finish on other side. So, in this way we can represent few more welding types, which is the form of weld will be grinding finish, and the section will be looking like this. Section will be looking like this, and the drawing representation will be like this. This is grinding finish. So, this will be like this, and this is basically double bevel butt finished flush on arrow side. Here arrow mark on one section only indicates the section prepared for join. Prepare for joint. So, in this way the drawing representation will be there. So, another type of weld will be convex fillet. The section will be looking like this. Now, this will be basically convex. This will be convex. It will be something like this. So, this will be S, which is called size of weld. This will be also S. This is size of weld, and the throat thickness, which I will discuss later in details, which will be called throat thickness. T, this is throat, and this distance will be throat thickness, that I will discuss later in details. Now, the drawing representation will be very simple. it will be like this. Then you have to put an arrow mark, and then you have to tell in this way that S with convex fillet. So, this will look something like this. In this way one can represent. Another one is the difference we can see here, concave fillet this will be looking like this. So, basically it will be same type, only concave weld will be there. This will look like this, then it will come, then it will like this. So, this will be concave. So, this will be the size of weld, and throat thickness will be this one. So, this will be, so section will be like this. This is size, this is again size of weld, and to represent in the drawing this can be made like this. So, in drawing we can easily represent, only thing is we have to know the meaning of representation, how it is done. Now, this is looking like this, this is concave. So, concave sign will be given. Here black circle indicates that field weld, black circle here will indicate the field weld. Another is weld all round, the form of weld is weld all round. If it is like that, then the section will be like this. So, suppose one I section is given. Now, if I see in the 3 dimensional, it will look like this, and this will be forming in this way. These are basically forming by weld all around. This will be so this will be like this. So, that basically forming all around. So, drawing representation will be simply like this, just you give the I section and then just define like this. This is basically, this representation has been made basically to simplify the drawing, because in the drawing it is not possible to make all the details. So, if one knows the conventional things, then the user can easily read the drawing and can make the things properly. This circle indicates fillet weld all round the section. This circle, this is indicating that fillet weld is all round the section. So, in this way, very simple way we can represent a complicated one, and the construction engineer who is going to construct the building, steel building, they can use the drawing and accordingly they can make the things properly. Now, we will discuss about details about fillet weld. We have seen that there are different welding are there. One is fillet weld, another is butt weld, then plug weld. So, when basically two plates are left, then we generally use fillet welding. So, a fillet weld can be specified by the following parameters. One is size of weld, its throat thickness and the length. So, when we are talking about the fillet weld means what is the size, what is the throat thickness and what is the length of the weld. So, these three things we have to know while using the fillet weld. So, the fillet weld can be shown in this way. This is the weld which has been made to connect two steel parts. Now, if we see, this is called toe, this two part is called toe, and this is basically weld face of the weld. So, welding will look like this, basically two parts we are going to connect. So, this is toe and this is weld face, and this is basically fusion zone, and this point is called root. So, the leg will be this one, we can call this is as leg, and this side also we can call as leg. So, we can make it. So, in this way the fillet weld can be represented. Now, what is the size of the weld? The sides containing the right angle of the fillet weld are called legs, what I have shown here in the previous slide. The size of the weld is specified by the minimum leg length. So, the minimum leg length will be the size of the weld. The length is the distance from the root of the weld to the toe of the weld measured along the fusion face. So, here you see, so from the toe to the root, this is called leg, and the smaller of this two leg will be the size of the weld, which is represented by S. Size of the weld basically we used to tell as S. Next, as per the codal provision, some minimum size of the fillet weld has been given. In code IS 9595 in 1996, in the annexure A.2.1.8, the minimum size of fillet weld has been given. So, this minimum size depends on the thickness of the thicker part of the member. Thicker part of the member means the if two plates are joining, then the thicker part of the member will be the we have to consider. So, minimum size of fillet weld will be, say for up to 6 mm thickness it will be 3 mm. So, minimum will be 3 mm, and from 6 to 12 mm thickness of the plate, minimum size of the fillet weld will be 4 mm. For 12 to 18 mm size of the plate, the thickness of the minimum size of fillet weld will be 6 mm. If the thickness of the plate become 18 to 36 mm, then the size of the fillet weld will be 8 mm. Again, if the thickness varies from 36 to 56 of the plate, then thickness will be 10 mm. Similarly, for 56 to 150 mm, thickness can be increased to 12 mm, and if the plate is above 150 mm, then minimum thickness has to be given as 16 mm. So, minimum thickness has to be given as 16 mm if the plate thickness becomes more than 150. Now, you have to note the following points. One is when the minimum size of the fillet weld is greater than the thickness of the thinner part, the minimum size of the weld should be taken as the thickness of the thinner part. So, you have to remember this point. Another point is, when the thickness part is more than 50 mm thick, special precaution like preheating etc. will have to be taken care properly. So, this is another important part while joining the two plates with welding. Now, another parameter which is important in case of welding design is called effective throat thickness. Basically, the effective throat thickness of a fillet weld is the perpendicular distance from the root to the hypotenuse joining the two ends of the legs while reinforcement is neglected. What is this? That means, if our weld is something like this, then the perpendicular distance from the root, this is the root and this will be the perpendicular distance from the root. So, this will be the effective throat thickness. So, this can be calculated approximately. How? So, let us see, in case of effective throat thickness, if we see that if this is the size of weld S, if we call, then this is also size of weld. So, AB and BC will be equal, which is size of weld. So, we can find out the length of AC. AC will nothing but square root of AB square plus BC square, that means A square plus A square. So, AC will become finally root over 2 into S, right. Now, again, as this is a right angle, so we can find out the throat thickness T. This distance basically BD is called throat thickness. So, BD can be find out. So, AD will be basically half of AC and AB is S. So, BD can be find out from this triangle ABD. So, we can write AB square equal to AD square plus BD square. So, BD, this distance will be basically root over AB square minus AD square. So, BD will be root over A square minus S by root 2 whole square, because now AD will be becoming S by root 2, because AC is root 2S. So, AD will be AC by 2, that means S by root 2. So, BD will become finally S by root 2 after calculating this. S by root 2 means basically 0.707 S. So, BD, which is called throat thickness T, is coming 0.7 S approximately. So, throat thickness of the fillet weld can be defined as 0.7 S, where S is the size of weld. So, in this way we can calculate. However, always it may not be rectangle, right. For that the code has provided some guidance. For the angle other than right angle fillet weld, the value of throat thickness is given as T is equal to Ks, where T is thickness of the weld and S is the thickness of the T is throat thickness of the weld and S is the thickness size of the weld, and K will be a constant depends upon the angle between fusion face. So, this K basically it may not be right angle, which we have shown here, always it may not be right angle. So, if this angle differs, how the throat thickness is going to vary, that has been described by the code. So, if the angle between the fusion face becomes 60 to 90 degree in between, then this constant will be 0.7 S. So, T can be written as 0.7 S in this case, but if the angle become more than 90 degree, say from 91 to 100 degree, this constant K is becoming 0.65. This is given in the table 2 of IS 816. In this code it is given. If the angle becomes 101 to 106 degree, then this constant will become 0.6, and if the angle of fusion means angle between fusion face becomes in between 107 degree to 113 degree, then it will be 0.55, and 114 to 120 degree the constant will become 0.5, that means T will become in this case 0.5 S. That means the throat thickness of the weld can be find out from either from this table, or if it is not given, then assuming the throat thickness to be 90 degree, we can make that T is equal to 0.7 S. the way we have calculated. Now, another important parameter is effective length. The effective length of the fillet weld is the area of the weld for which the specified size and the effective throat thickness of the weld exists. That means, effective weld basically will be the overall length minus 2s. So, when we are calculating the length for the design purpose, the effective length will be the overall length whatever is given minus 2s. So, the effective length should not be less than 4 times the size of the weld. This is another condition has been given by the code, that minimum length should be greater than 4s, where s is the size of the weld. If it is not, then what we have to do, that size of the weld must be taken as the 1/4 of the effective length. That means, the size of weld has to be decided in that way. And finally, you have the designer have to remember that overall length will be more than the effective length. So, whatever effective length is coming, you have to add plus 2s to make the total length, means the overall length as L. So, L will become basically L plus 2s, where s is the size of weld and L is the effective length. So, when we are going to get the effective length, we have to increase the overall length by 2s. Now, maximum size of fillet weld, that has been guided by the code, as the maximum size of fillet weld will be the thickness of the thinner plate minus 1.5 mm. This will be the maximum size of the fillet weld, thickness of the thinner plate minus 1.5 mm, and this will be 3/4 of nominal thickness of angle. If it is connected by the angle, then this will be 3/4 of nominal thickness of the angle. So, now we will go for discussion about the design of fillet weld. But before that, we have to know few terms which are used for designing the fillet weld. Out of this, first 3 have already been discussed: the size of fillet weld, which is termed as S, how to find out, and the throat of fillet weld, the throat thickness means T, and effective length of the fillet weld, where L is equal to basically L minus 2s, and this T will be equal to 0.7s in generally we used to make. Now, other terms we have to know while designing the while designing the members by using the fillet welds. One is called end return, this term we have to know. Another is overlap, side fillet, intermittent fillet weld, single fillet weld, and another is permissible stress and strength of fillet weld. Those things we have to know in details, otherwise we will not be able to design the fillet weld properly. Okay, so the terms we have to know now. One is end return. In case of end return, let us see how, means what is the end return. If one plate is joined with another one, now welding has been done in here and up to this portion is called return ends. That means the fillet weld terminating at the end or side of a member should be returned around the corner whenever practicable for a distance not less than twice the weld size. This also we have to remember, that it should not be not less than twice the weld size. That means this distance will be at least 2s, it should be more than 2s. Another term which we used to make is called overlap. Overlap means the when two plates are joined by some overlapping, say like this, force is acting in this, then this is called lap. This should not be less than 5t. This is called overlap. This should not be less than 5t, where t is the thickness of thinner plate. And next is intermittent fillet weld. Intermittent fillet weld, that is next is intermittent fillet weld. So, here the length, intermittent fillet weld length should not be greater than 12 T when it is under compression, and this should not be less than should not be greater than 16 T for tension, and in any case should not be greater than 20 centimeter. So, intermittent fillet weld length should not be greater than 12 T for compression and should not be greater than 16 T for tension and should not be greater than 20 centimeter in any case, and where T is the thickness of thinner plate. Now, another term which we use generally is called single fillet weld. A single line of fillet weld, when it is used, another term sometimes we use is called single fillet weld. It should not be used while subjected to bending. That means, once again I am repeating. Another parameter, another term which we use is called single fillet weld. Basically, single fillet weld should not be used while subjected to bending. So, this we have to remember, when the members are subjected to bending, then we cannot use this single fillet weld because it cannot take care. Another important parameter which we have to know is that permissible stress and the strength of fillet weld. As per IS 816 1969, the strength of the weld can be calculated as P is equal to PQ into L into T, where T is throat thickness. This T is called throat thickness, and that can be calculated as K into S, where K is the constant which depends upon the angle and S is the size of weld. So, from this we can find out the throat thickness. Another is L. L is the effective length of the weld, that means basically the overall length minus 2S, and PQ is the permissible stress. Taken in general 108 MPa. For welding cases, the permissible stress of the weld has been taken as 108 MPa. So, P will be the strength of fillet weld will be basically PQ into L into T. So, from this formula we can find out the strength of the weld, and accordingly we can design the joint. So, in today's lecture we have emphasized on welding connection. In welding connection, again we have discussed the different aspects of advantages and disadvantages of welding. Now, as per the requirement of the designers, we have to choose the process of welding, means what type of welding we are going to do, and different type of welding process has been discussed, and the different drawing representation for different cases of welding has been shown, from which one has to know the meaning of drawing, what the drawing is saying, and accordingly what we have to make in case of construction. So, those things from the drawing we have to understand, and the how to design a fillet weld, that also we have discussed today. The basically how to find out the strength of the fillet weld, that we have discussed, which is basically given by the formula that P is equal to PQ into L into T, where PQ is the permissible stress and L is the effective length and T is the throat thickness. And what is effective length, what is the throat thickness, what is the size of weld, what are other parameters required. So, all the details we have discussed. Basically we have emphasized on fillet weld. So, next class we will design a connection using fillet weld, and how the strength can be calculated in a connection, that we will discuss in next class. Thank you.